here is a hard question. I didn't put anything like hard like this on the test, but think about whether or not it's true. So I wrote it on the board because he asked the first question are each variable, is it bound to a particular quantifier or is it free? So first look at this and say which variables are bound to which quantifiers, right? So this one is clearly bound here. This one's clearly bound here. And this one is free. Right? Everybody kind of agree with that so far? Right? So if I change this one to a y and this one to a z, does it change anything in the meaning? Right? No, it's just local. The local, like if you had a little for loop, the local variable doesn't matter. Everybody in agreement? All right. So then we have to think about what free variables mean, right? And they're a little, they have confused me, all right? And if they have confused me, I'm quite sure they've confused you, right? So what they are is, let's put a big outside around this sentence and say, well, if we're saying this sentence is valid, then it needs to be true in every model, right? And that's, every definition of what your objects are, every definition of what your A and B are, and every definition of what objects you assign to your free variables, right? So you can kind of think about this as a big for all x out here handling this free variable, right? Does that make sense? I'm saying no matter what, I mean, we've often said if I have right, there could be whether this is true or not depends on the value of the free variable we stick in. So I could define, here's this sentence is called fun, and you plug in an object for x, and it's either true or not true. Right? People buy that? So if we want to test, is this thing true for every value of x? Well, let's first think about whether it's true for your favorite value of f, right? X. So let's just plug in here, I like Jeff. Let's put in Jeff here. Now, if I tell you, what does this tell me? This tells me if we have A here, and here are all my objects, then A is true everywhere, right? And what does this say? This says B. Well, actually, it only tells me that B is true for Jeff, right? And what do we want to imply is that B is true everywhere, right? So is this true? Is this valid in every universe? No, right? It's not true in every universe, right? Does that make sense? Are you with me here? Yeah. Yes. Yeah, this is a local variable, right? This says B is true everywhere, right? So this says the boss gave me some value for my free variable. And if B is true for that value, then it's true everywhere. Right? And is that true? No, it's not true. Right? Everybody see how that's not true? And I had slides, which I'm pretty sure we did cover, called free variable scary. Right? And this is what it was doing. Right? Does that make sense? Yeah? No, because free variable meaning it's true in every universe. I would say in every universe there's a fixed value, right? But given that for it to be valid, I would say if you give me your favorite universe in which the X is Jeff, then in this sentence might be true in that universe, right? But for it to be valid, it needs to be true in every universe. And to be true in every universe, it needs to be true not just for every X, for every X, for every A, for every B, right? This is the for every universe statement, right? Does that make sense? All right. More sense. Good. Good. All right. All right. Well, I'm glad it makes more sense. But also, I'm when I go through and I read individual lines, I have to think, what does it mean, right? And so I have this meaning that free variables are quantified. Yeah. Right. Now the scary thing is, how do we go about, I mean, this happens not to be true, right? Valid. So we shouldn't be able to prove it. But what scared me when I first was doing this was trying to prove it. So if I was trying to prove it, then I would say, by deduction, right? We're proving, right? Left-hand side gives me right-hand side. And then I would assume for all, let's keep it as y's so we don't get too scared. And beta x. And then I guess if we're doing it formally, then we put the assume over here, right? Not that it, in my opinion, really matters, right? One looked more English and one looked more proof, right? And then what do we do here? Purple table, we separate, right? And then, well, now this is a free variable, right? And free variables, you can add a bx for all x on front, right? Because this is saying it's true for every x. So now we have for all x, right? And then we can conclude our deduction, right? Everybody follow this proof? Sorry. You might be better slightly over. How are you guys doing with this? Is it a good proof? Exactly. It shouldn't be, right? It shouldn't be. And that's where I panicked, right? That's the panic, right? So then I talked to George, and George said, well, I told you should be doing it my way. And what he would say is, when you're about to do this step here, you look back and you see, was this X in a in a free variable of an assumption, right? And if it is, you're not allowed to do this step, right? And so I just changed it because I like things local. And I said, when you make an assumption and you have a free variable, right? This is a free variable on the left-hand side that we're assuming. I said, just put a little arrow under it, right? So we got a little arrow here. And what does that arrow mean? Well, it means that the for all's here and not here, right? If I move this for all here, it would become true, right? When the for all's out here, it's not true, right? What this guy here means, it is any object you want, but it's only one object. For the duration of this proof, from when we assume to when we conclude, this is any object, any one object. Yes, if we bring it in here, what this is Jeff. We brought it in, it's arbitrary, but it's one object. And now this is one object, so you can't do a for all on it, right? Yeah, yeah. So let's just change this for a minute. Let's change this to an exist X. So is that true? Right? If it's true for Jeff, if it's true for anybody that my adversary gives me, then there exists somebody who's true, right? And so that lets me over here. Okay, now I know that there's some guy there, so I can bring in the exist X, right? And then my conclusion is that is this thing over here, right? And the advantage of this thing over here, well, I proved it, and now this is a free variable again, right? When I conclude, I drop the specific, right? Because when I proved it, I let this be an arbitrary but specific, and then I prove this, right? And now this is true for an arbitrary, right? So in my next line, if I want, I can add the for all X, right? To the entire thing, right? Because this entire thing has a free variable. So this for all X applies to the entire thing. Guys, it makes perfect sense.
Still may screw it up.
Yeah, I'm with you. I'm with you, right? And all these, what I say, this is where George and I did. Yeah, I'm never going to remember all of George's rules, right? And so I like to have meaning. I can kind of hold on to meaning. I can look at this and say, is this true? No, it's not true. So why isn't it true, right? And I make it up each time, right? So you can either be memorizing things or you can be making them up each time based on, right? And I say the more understanding you have, the better you'll be 20 years from now, right? Because I believe you'll hang on to understanding and you won't hang on to memorizing rules. Now, if you're in a panic about this, I do say this is a little harder than the test. I don't test you on this. I'm pretty sure I don't. I'm most one question, right? Yeah? Well, there certainly are questions, and this is where I could be wrong, where there are questions where I lay down sentences like this. And you simply have to say, oh, actually, here's a bug in the exam. I think it's a true false question, right? So it's really, is it valid or not valid that matters, right? So I'd say true, false, I lay this down. And you just say, it's valid, it's not valid, right? Well, you can bring in blank paper. There's blank. I think the last page is blank, and you have to hand in the question sheets, but no one is ever going to look at them. I scan them in to make sure they're handed in, right? And yeah, I was very careful during the 31 to make sure they're all handed in, and you know why I'm doing that. Because there's a post-strike, right? There's a post. Oh, have you heard? They're voting on Friday whether to accept the deal. I just learned that I went from rich to richer myself. They gave, Ford said we only could have 1% a year, and they gave us retroactive. So, man. Yeah. It's nice, right? I'm sure it's gonna, yeah. Any other thoughts? Yeah. My brain is the same. I didn't catch your nuance, but I will say that on a multiple choice test, you don't have to do it at all. I might say, am I doing it right? And know that I'm pretty casual about those things. So if it feels logically or somethingly right, then call it right. Yeah. No, just no. What the conclusion here was you put a circle around the entire sentence and you put a for all on the outside. Oh, well, if it was actually a free variable, you could go to a for all, but it's a FACO variable. So you can't, the reason I changed to exist is so that we could actually finish our proof. Yeah.
The step of adding, would it be necessary that because AX and PX implies for all X BX, right? That wouldn't.
If this wasn't here?
That wasn't there.
Oh, if more, you would need both of them then. Yeah, because they're both free variables, right? I only added this one because you asked, how do you tell what's a free variable? And so I put something up to make it less clear which the free variables were. Yeah.
That step starts with very long.
Yeah, if your assumption has no free variables, then you don't need to add this thing. You only add it to free variables. And so then, yeah, if it had a for all, you could remove it and add it back. And yeah, it's
Only if it's down.
Yeah.
Down going in one of the two little.
Yeah. Yeah. Yeah, and I would, my first reaction would say I would never do this, right? In reality, but I can imagine saying, hey, x plus 1 equals y implies that x plus 2 equals y plus 1, right? I can imagine writing this down and everybody saying, yay, right? But here I've done it, right? Because I didn't tell you the value of x. So x is sort of a free variable, right? And it would be very different to put these here and here than putting them on the outside, right? When I write this sentence just on its own, I assume that this is a free variable, but it's the same one over there, right? That it's only one at a time. For the duration of this discussion, x and y are fixed, right? In fact, it came up on the 3101 exam where I had a statement with an x here and a statement, all within the same paragraph. And the number of people who asked me, are these the same x? And I didn't say, come on, dude, you should have taken 1090 and know that this is a free variable. So there's a for all x on the outside, right? It's the same x. Everybody good with that?
So like on your first statement where you have it for all x.
Where brackets? These brackets. Yeah, at one point this term, I would looked up what is the level of where assume brackets, and I was surprised, right? Is the assume here, is the assume here? And I think the assume is here, right? But we never require anybody to remember that, right? I wouldn't require myself to remember that. If I saw this, if I was writing it, I would put slightly more blank space to help, right? But hopefully that, I don't think I'll give you a hard time that way.